Welcome to this session. In this session, we define conjugate of a matrix and then give some examples. So the conjugate of a matrix, let A be this matrix given by alpha 1, 1 plus beta 1, 1i, alpha 1, 2 plus beta 1, 2i, up to alpha 1, n plus beta 1, n I, and then alpha 2, 1 plus beta 2, 1 I, alpha 2, 2 plus beta 2, 2 I, all the way up to alpha 2n plus beta 2ni, and then alpha m1 plus beta m1i, alpha m2 plus beta m2i, up to alpha mn plus beta mni. So let this one be a complex valued matrix. Be a complex valued matrix. Then the conjugate of A is denoted by A, then you write a bar on top, and is given by so simply now, like the way we deal with complex numbers, you get the conjugates of these elements. So where the sign is plus, then changes to minus. So the conjugate of this matrix will be so we'll have alpha 1, 1 minus beta 1, 1i, alpha 1, 2 minus beta 1, 2i, up to alpha 1n minus beta 1ni, alpha 2, 1 minus beta 2, 1i, alpha 2, 2 minus beta 2, 2i, up to alpha 2n minus beta 2ni, all the way up to alpha m1 minus beta m1i, alpha m2 minus beta m2i, up to alpha mn minus beta mni. So yeah, the same way we deal with complex numbers. The conjugate simply change the sign from plus to minus. Now, a more specific example, if you have the matrix if, so this is an example, A is given by 1 plus I, 2 minus 3i, 4, and then 7 plus 2i, and then minus I, 3 minus 2i, 2 plus 3i, 4 minus 3i, 2i. Then the conjugate of A is, so this how we write the conjugate. And then the usual way we deal with complex numbers, so element by element. So this we change the sign to minus, so 1 minus I. This will be 2 plus 3i. Now remember, this can be written as plus 0i, so plus minus 0 doesn't change the value, so it remains to be 4. This one will be 7 minus 2i. Now this, like we have 0 here, so 0 minus I, so it will be 0 plus I. So this will now be I, or say plus I. 3 plus 2i. This will be 2 minus 3i. Here we'll have 4 plus now 3i. And this now is like we have 0 plus 2i. So therefore now it will be 0 minus 2i. So we'll have minus 2i. So this is the conjugate of that matrix. And then there's some matrix we denote by A raised power theta. So the matrix A power theta. So the transpose of the conjugate matrix conjugate, the transpose of the conjugate of a matrix A is denoted by A raised power theta. So e.g., given A to be the matrix 1 plus I, 2 minus 3i, 4, and then 7 plus 2i, minus I, and then 3 minus 2i. Then let's see how we identify this matrix A raised power theta. So the first thing, we get the conjugate, which will be given by, so this will be 1 minus I, 2 plus 3i, 4 remains to be 4. This will be 7 minus 2i. This minus I now becomes plus I, and then this one is 3 plus 2i. So that's the first step. You get the conjugate of the matrix. So A power theta is the same as the conjugate, the transpose of the conjugate matrix. So therefore now we simply get the transpose of this new matrix we have here. So therefore A power theta is this matrix. So this will be 1 minus I, 2 plus 3i, and then 4. And then here we have 7 minus 2i, I, and then 3 plus 2i. So that is what we call the matrix A power theta, the conjugate of the matrix obtained by finding the transpose of the conjugate matrix. So that's what we have. And then let's give another definition of what we call unitary matrix. Unitary. Remember, unitary is different from unit. Unitary matrix. Unitary matrix. So a square is said to be unitary if it's A power theta times the matrix itself is an identity. So this simply are dealing with a complex valued matrix. So say a square matrix A is said to be unitary if A power theta times A is given by an identity matrix. And remember, A power theta is a matrix obtained by getting the transpose of the conjugate of the matrix A. So for example, if we have a matrix A given by 1 plus, remember unitary matrices, we are talking about complex valued matrices. That's when you define the unitary matrix. So I1 plus I divided by 2 minus 1 plus I over 2, 1 plus I over 2, 1 minus I over 2 is unitary. Let's prove that this matrix is unitary. When you say unitary, it means that now A power theta times A should give us an identity matrix. So proof. The first thing we have to get the conjugate of the matrix A, which will be given by 1 minus I over 2 minus 1 minus I over 2, 1 minus I over 2, 1 plus I over 2. Or we can write it the same as a half minus a half I minus a half minus a half I, and then a half minus a half I, a half plus a half I. That's the same thing. Now, once we have defined the conjugate of the matrix, then you transpose it to get the A raised power theta. So A raised power theta, so this implies that A power theta so A power theta, which is the same as A conjugate transpose, will be, now we already have the, so simply now this will be the a half minus a half I, and then this becomes negative a half minus a half I, and then we have a half minus a half I, a half plus a half I. So that is the theta. Now we have to show A raised power theta. We have to show that now A power theta times the original matrix A, we get identity. So let's see. So we'll have a half minus a half times a half I, a half minus a half I, minus a half minus a half I, a half plus a half I, times the matrix A itself was a half plus a half I, and then we had negative a half plus a half I, and then a half plus a half I, and then a half minus a half I. So if we get that the product here will give us an identity matrix, then it's true that the matrix given is unitary. Now, so you see this one here and this one here is a difference of two squares. Remember, difference of two squares is A minus b, a plus b is a squared minus b squared. This is like we are squaring a half and then minus a half I squared. So a half squared is 1 over 4 minus 1 over 4 I squared. But I squared is -1. So -1 times -4, -1 over 4 is +1 over 4. So we'll have 1 over 4 plus 1 over 4, which is 2 over 4 or a half. So this times this one is a half. And then also this one here and this one is a difference of 2 squares. So it's also a half. So a half plus a half gives us 1. Now, this times this one here. So we'll have a half times negative a half is -1 over 4. A half times 1 over 2i is plus 1 over 4i minus 1 over 2i times minus 1 over 2 is positive 1 over 4, and minus times plus is minus. A half times a half is 1 over 4, but I times I is I squared, so we'll get plus 1 over 4. So that will give us, remember there's an I here. Because we had just create space here to work out this one properly. So we are trying to multiply this. We have done this product and then this one, that's square plus 1. So this by this one here, we have a half. So a half minus I over 2 times minus a half plus I over 2. So I want to get this product and this one here. This by this will give me minus 1 over 4. This by this will give me plus I over 4. This minus minus is plus. So I'll have I over 4. And then minus plus is minus, but I times I is I squared, which is -1. So it'll be plus, and then 1 over 4. So this and this one cancels out. So we'll have 2 over 4i, which is a half I. And then here, this time this one here, we'll have a half minus a half I times this a half minus a half I or I over 2. So this by this will give me 1 over 4. This by this will give me minus I over 4. And then this by this will give me minus I over 4. Minus minus is plus, but I times I is I squared, which is -1. So I'll have minus and then 1 over 4. So this and this cancels out. So this will give me minus 2 over 4i, which is minus a half I. I remember I had a half I, so plus minus a half I, so I get 0. And similarly, if you work out this product and this product, the answer should be 0 here. And just to confirm that the element there will be 1, let's compute that operation. So what's assumed here is that you know how to deal with complex numbers. So I want now to get this times this. So I'll have minus a half minus I over 2, this element here, times minus a half plus I over 2, this element here. You see this is still a difference of two squares. So it's the same as negative a half squared minus I over 2 squared. A half squared is minus half squared is 1 over 4. I over 2 squared is I squared over 4. I squared is minus 1. So minus minus is plus. So a quarter plus a quarter is a half. And still this one here and this other product here is still a difference of two squares. So we'll also get another a half in this product. And when you add to this half we got here, we get 1. And this is an identity matrix. So since A power theta times A is giving us an identity matrix, then A is unitary matrix. So that's how we prove that the given matrix is unitary. Simply the first step, get the conjugate of the matrix given. Once you get the conjugate of the matrix given, get transpose of that conjugate matrix. So the transpose of that conjugate matrix is what defines A raised power theta. So with that matrix, multiply by A, and then if the working comes out to give you an identity matrix, then you conclude that the matrix A is unitary. Thank you.